Good evening, friends. My name is Vijay Tummala, and I am today in front of you in order to present a presentation on research methods. The order in which I'm going to explain my presentation over today is the research question, the CTOD and its applications in marine structural steels, in aircrafts, and in pipelines, the research design, the advantages of my research design, and then the limitations of my research design, and the final 2 minutes of a few questions. So the research question. The research question that I have chosen from the topic of CTOD is the study of the resistance offered by a sent specimen of X80 pipeline steels when they are subjected to constant unloading procedure. So CTOD and its applications. So CTOD, the crank tip opening displacement test. So what is CTOD? CTOD is the resistance offered by a material when it is given crack, and the resistance to the cracks, the propagation of crack or to the opening of a crack, is the CTOD test. It is mainly used in areas which covers uses materials like steels, aluminiums, chromiums, and other alloys. So these are mostly used in fields of marine engineering, aeronautical engineering, and pipelines. So why is this that necessary? CTOD is mainly to know the resistance of the material for these external forces. For example, materials in submarines, in pipelines, and in aeroplanes. All these are faced to external forces, high external forces like wave pressure, air pressure, and internal fluid forces. So in order to sustain these, the material needs to have a certain fixed values of resistance. So this test is for those. So the CTOD in marine structural steels. We know that marine engineering consists of lot number of fields like submarines, building, oil rigs, and all. So why is it so important in these fields? For example, let us consider submarines. Submarines are most necessary for underwater travel and for army and security. So we know that water pressure increases by the depth we go. So the more the depth, the more the water pressure. When the material goes more, it faces a high amount of external forces like water pressure in it. So when during the manufacturing of these submarines, the CTOD is considered in the beginning itself. The most important material that we use in this is X65 steel. So this is considered because it has a higher value of higher sustainability and higher value of strength to mechanical external forces. So CTOD on aircrafts. Aeronautical engineering. Aircrafts experience pressure from the air with the increase in the altitude. Aluminium is the most important surface material for the aircrafts. Aluminium has a very special material which has high mechanical resistance and it has very high fracture points. It is very resistant to external pressures and cracks. The only disadvantage of this aluminium is that when a crack is obtained or when a crack is made, it has a very less resistance for this crack propagation and all. It's very fast. The most important aluminium alloy that we use in this manufacturing is 2034 T351. CTOD on pipelines. So pipelines is a very old traditional way of transport of oil and natural gases. A large number of industries use this conventional method in order to transfer these oils and all. So the materials used for this pipelines are mostly of steels, cast irons, and aluminiums. So in steels, why steels? Steels have very high mechanical properties and are very compatible for mixing with alloys. So sent specimens. So these specimens are few specimens in which X80 steels, X70 steels come under. And in order to test these specimens under CTOD, we use torsion and a J integral which helps in these factors. So these pipelines need to sustain the internal pressure obtained by exerted by the fluids or the gases, and even the external forces like corrosion and atmosphere changes. Underground pipelines and all generally use X80 type of steels for the manufacturing. the design. So the design of my project is in this following manner. The CTOD and the sent specimens are generally calculated using a traditional formula in which the pressure and the volume are calculated like the PVG, and the graphs of them are obtained. The resistance values of these are calculated by obtaining the peak points of the pressure and on the volumes. So this is the traditional way. By this way, we get the resistance offered by each material, only the resistance offered by the materials. So CTOD is not only for resistance. Knowing the resistance doesn't even help the whole process. There are some other forces like strain hardness, the stress, and the axial loads that are to be determined in order to test the following compatibilities. So in my approach of design, I've also integrated another method called NPL factor, in which the axial loads of Ux and Uy are described, and an external factor called F is determined, and the yield and tensile ratios are also determined, and all the simulation of these gives a final integer called J, which is the sum of the elastic limit and the plastic limit. All these values are tabulated and the corresponding resistance values are noted. By solving these resistance values with the pressures, we get the strain hardness of the materials even. So the advantages. The major advantages of using this type of approach is it integrates both the old and the new traditional ways of traditional ways. It helps giving in a better efficient manner, results in a better efficient manner with high accuracies and with less investment costs. The disadvantages. The limitations of these are that these require a lot number of individual tries for the specimens in order to calculate the parameters, and so this is a lengthy process which requires more number of trials. Any questions? Thank you.